Internal energy. So what is the internal energy? Please write. Internal energy of a system. Internal energy of a system is the energy possessed by the system. Is the energy possessed by the system. Is the energy possessed by the system due to molecular motion and molecular configuration. So therefore, U internal U is equal to internal kinetic energy UK plus internal potential energy. Internal energy U is equal to kinetic energy, internal kinetic energy plus internal potential energy. Now, this is the internal energy. You can say U. Below right this in that point 1. This point 1. Right. For an ideal gas, there is no molecular attraction. For an ideal gas, there is no molecular attraction. Then, so potential energy is equal to 0. There is no molecular attraction, then potential energy is 0. Next, therefore, internal energy of an ideal gas is totally kinetic energy. So U is equal to UK, internal kinetic energy. So that is equal to 3/2 nRT. For ideal gas, this is the internal energy. So there is no molecular attraction, then the potential energy becomes 0. Next point. In case of gases, whatever be the process, delta U is equal to N into F/2 into RT. F/2 into RT. T means already delta I written, delta T, right? Change in temperature. That is equal to NCV delta T. NCV delta T. So that is equal to N into R plus R by gamma minus 1 into delta T. Cp is equal to gamma minus, Cp is R by gamma minus 1 into delta T. Now we are going to, that is equal to continuation. N into R delta T what? T2 minus T1 divided by gamma minus 1, adiabatic process. So that is equal to P2 V2 minus P1 V1 by gamma minus. How you got from this one? So R we are taking R T2 minus R T1. So that implies PV is equal to nRT. PV is equal to nRT formula. So that means PV is equal to nRT. So this is already we are having RT2. RT2 means what? Then P2 V2. So suppose R T1 is the meaning what? P1 V1. So this is expect we get this. That's it. Here F is the degree of freedom. F is nothing but degree of freedom. Right. Next point. Change in internal energy. Change in internal energy. Change in internal energy does not depends on path of the process. Change in internal energy does not depends on path of the process. We stop. So it is called a point function. So it is called a point function. It depends only on the. It depends only on the initial and final states of the system. It depends only on the initial and final states of the system. Final states of the system. Like any system is not path independent. Path independent is linear. So you may go like this, and you go like this, and it will go like this. So the initial position is the final position. So therefore, du change in energy is equal to internal what is called final energy minus initial energy. So this is called path independent, and also called point. This is path independent. Path independent. Underline point function. So, change in energy does not depend on the path of the process. So it is called a point function. Please underline point function. Next, take the problems. Point function. So point function. Right. Now take problems. With the problems. No. So understanding a thermodynamic system is taken through problems. A thermodynamic system is taken through A thermodynamic system is taken through the cycle. A thermodynamic system is taken through the cycle PQRSP process full stop. The net work done by the system is by the system is. So you take this figure is given, then go to the figure is given. This is the volume, this is the pressure. They are taken a closed system. Okay. Now this is 1000 cc. Cc stands for cubic centimeter. This is a 3000 cc, and this is what we call 100 kilopascal PA. This is a 200 kilopascal. That's all. PA bit so now they're asking you to find what the net work done. What is the net work done by the system? Then you can say P Q R S. This is a part P2. So how is done? P Q S. No problem. Right. So we have to find what area of this one. So what is the work done area under the curve? So how to find area? This is a rectangle. This is a rectangle. Do the right answer. Solution. Sai, how much answer? What is the answer? So work done is equal to area. Work done is equal to area under the curve. Area of the loop or area of the loop. Area of the loop. So area of the loop here is what you can say. So this is the length into breadth. What is the length? This minus this. 300 plus 3000 minus 100. 1000, sorry. Into what is this one? This is the length into breadth. Present. Kilo. All are kilos. So 200 minus 100 minus. This is what? Kilopascal. Kilo under 10 to the power of 3. Now this is a cubic centimeter. So this is in SS system. 1 cubic centimeter is equal to how many meter cube? Cubic centimeter cc is equal to dash meter cube. So conversions. So centimeter, that means cubic centimeter cube is equal to dash meter cube. So already we know what the size, what the answer. So 1 centimeter is equal to 10 to the power of minus 2 meter. So therefore you can get 10 to the power of minus 2 minus 6 meter. So you have to multiply this one. So either here or there. So 10 to the power of 6. Right, complete. Yes? 20. What do you need? Joule. It is a clockwise is minus or plus or? It is a clockwise. Clockwise is positive, anti-clockwise is negative.
Yes.
One thing, first you simplify. This is 200. So what you do? 1000 you take it out. Common. 100 you can take it. 10 to the power of 5. So this gives you 5. Now what is the difference? 10 to the power of 5. If 10 to the power of 8, then if you cancel 10 to the power of 2, 1000, you take 10 to the power of 3. This is 200, 100. So this is what? 3 minus 1, 2. 2 minus 1 is 1. 2 into 10 to the power of, how much you are getting? Already 6 is there, minus 6 is there. Then what is that? Written here is what? 3. 3 plus 2, 5. Sorry, this is totally 5. This is 3. This is a 2, but kilo is there. So I can say a kilo Kilo written. No, sorry. So this is a 3, 2. What about kilo? Like another 3 is no? Oh, 8 correct. I can say otherwise kilojoule. 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 Kilowatt, where have to take kilo? That's all. Understood? Kilo, keep it outside. 3 to 5 minus 6 plus 5 is minus 1.
Plus 3.
Plus
3.
3. That is 2. So then 2 into 10. 2 into 10 to the power of 2 joule. So I can keep kilo as it is. What to do? Kilo is not important. 0.2 kilojoule. Okay. Are understanding, man? So once again we check it ourselves. This is a 10 cube, 10 square, 10 to the power of 5. I will keep aside kilo. Better. Okay. Minus 5, minus 6 plus 5, minus 1. Okay. No need to worry about it. This is minus 1. So 10 to the power of minus 1. So 3 minus 1 is 2. 2 minus 1 is 1. So 2 into 10 to the power of minus 1. That is 0.2 kilojoule. We should have to be worried. That's so either case 0.2 kilojoule. Right. So it is a negative or positive work done. So anti-clockwise is going away. This is called negative work done. Clockwise is positive work done. Right. So this is called positive work done. Are understanding? Right. So that is, this is a work done. What is the loop is? Positive. Clockwise means right. Positive work done. Anti-clockwise negative work done. Right. Next question, please. An ideal gas. Next, an ideal gas is taken around. An ideal gas is taken around. An ideal gas is taken around ABCA as shown in the figure. As shown in the figure, the PV diagram, please stop. The work done during a cycle is, 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 okay. Now see this one, draw the, they are given the diagram. This is the volume, this is the pressure. So like this they are given, please see this one. The shape is given a triangle, right angle triangle. A, I can take a B, C. A, B, C, A. This one. So how that is? The loop is A to B, B to C, C to B. Is it a clockwise or anti-clockwise? So what is the work done? Positive or negative? Positive. First we have to do that also. Sign is most important. Clockwise means positive, anti-clockwise negative. It's very simple. Screw going inside. Screw coming out negative. So now this is the coordinates of A is P comma B. The coordinates of B is 3P comma 3V. The coordinates of C is P comma 3V. That's it. So you want to find what is the work done. So work done, what is the formula of work done? Work done is equal to area of the loop. Area of the loop. So it is a right angle triangle. 1 by half into base into height formula. Half 1 by 2. This is the base. So this is the base. So base Then you have to find out what to say. Which is now it is pressure. This is the pressure. Pressure is sunna. So this is the volume changing. Pressure is constant. No, pressure is constant. What is the volume? 3V minus V. 3V minus V. Pressure difference. That is, this is what you call 3P minus P. 3P minus P. Then what are getting now? So this is a 2V, this is a 2P. Cancel. How much you are going to get? 1 by 2 into 2V into 2P. So answer is 2PV. Answer is 2PV. If it is a clockwise means positive because of clockwise. Positive for clockwise loop. Clockwise loop. Negative for anti-clockwise. That's all. You have to know the positive or negative word. Copy this. All right. Completed. Right, next. I take the problem. If CV is equal to problem, if CV is equal to 4.96 calorie per mole Kelvin, then the increase in internal energy, when temperature of 2 moles of this gas, is increased from 340 Kelvin to 342 Kelvin. Okay, right. So what is asking? Here's the problem. If CV, what is CV? Specific, what is called? Gas at constant volume. Specific heat of a gas constant at a constant volume. Constant volume at constant pressure. CV at a constant pressure. Okay. CV is the gas at a constant pressure. Right. So that value is given 4.96. Okay, sir. So increases in internal energy then when temperature of 2 moles of this gas is increased from 340 Kelvin to 240 Kelvin. What is the internal energy? Du is equal to NCV delta T plus. No substitute. How many moles are there? 2 moles. What is CV value is given? 4.96 calorie. Next, temperature in Kelvin is given. If they are given degree centigrade, you have to convert to degree centigrade. See here, unit, check it out. The most important is what the unit is given? Kelvin. So that is Kelvin is there, no problem. So that's why divided by CV is given temperature difference 342 minus 340 over.
So 19.8.
19.84. What is the unit of? Calorie. Because by checking this one, calorie. If supposed to be they are given calorie per mole degree centigrade means you have to convert Kelvin to degree centigrade. Suppose Kelvin to degree, what the difference is 2 Kelvin. So 2 Kelvin is equal to how many degrees centigrade? So that is what the conversion K plus 273 plus degree centigrade. Which one? Absolute Kelvin. Now we want a degree centigrade means 2 minus 273 is a degree centigrade. That we are going to get minus 271 if supposed to be, that's why degree centigrades. If it is supposed to be. So you should have to be care about in entrance exam. The units you have too much care you have to take. What unit they are given. That is system. Everything is fine. You just be careful, observe it. If it degree centigrade, it is a Kelvin is given, you are not done like this, the entire problem goes out. Right. But then the method is correct. But you are not taking care about the units is very dangerous. Right, sir? Now please write. Next one. The relation between the internal energy U, and adiabatic constant gamma. The adiabatic constant gamma is right. The relation between U and adiabatic constant gamma is there are asking. Now you are going to U is equal to NCV delta T, that is equal to N CV is equal to R by gamma minus 1 into delta T, absolute temperature. Now that means that is equal to, this can be written as what? PV by gamma minus 1. PV by gamma. So there is a PV by gamma. What is the relation? U is equal to internal energy and adiabatic constant. Number of moles is 190. So I'll take this from comparing this. NM cancels, delta T is nothing better. So U is equal to this. So CV is equal to R by gamma minus 1. What is the CP? What is the CP? CP is equal to gamma into R by gamma minus 1. What is CP? How you got? So CP minus CB is equal to R formula. This is called Mayer's formula. From this only you got it. Then how you got? Gamma is equal to what? Cp by Cv. From this you got this one. So substitute it. What you call as the Cp is equal to gamma Cv. That's all. Simple. Understanding? From this relation, Cp are getting, Cv are getting. It is called Mayer's formula. Right? Next right is Joule's law. All of right? Joule's law. Answer. Joule's law. So Joule's law, from Joule's law, you have one question you are going to get. See this one. Joule's law. First complete this one. Joule's law. Regularize. Whenever heat is converted into mechanical work, or mechanical work is converted into heat, then mechanical work is converted to heat, then the ratio of work done to heat produced, is always remains constant. So That is, work done is directly proportional to heat produced. So therefore, work done is equal to some constant, Joul's constant into Q. So therefore, you can write J is equal to, constant is equal to work done by Q. Work done by Q. Where J is equal to mechanical equivalent of heat. J is equal to mechanical equivalent of heat. Then we write it as values 1 calorie is equal to 4.18 joule or approximately 4.2. All of you know this values. Right, sir. All right, applications. Right, applications. Joul's law applications. Applications. Okay, right. When water in a stream, falls from height h, small h. When water in a stream falls from height h, so height h. Falls from height h. Falls from height h, the potential energy PE is converted into heat. The potential energy is converted into heat, and the temperature of water rises slightly, now. So the work done is equal to JQ. So what is the work done? mgh, potential energy, mg height h is equal to J. Then Q is equal to what formula? Mass into specific heat into delta T. So then this mass cancelled. Then rising temperature, whatever you want to find, rising temperature delta T is equal to what you call it? Delta T is equal to GH by J. J is specific heat of water. What is specific heat of water? 1. So specific heat of water is equal to 1. What is the calorie per mole? A degree centigrade. So a degree temperature means specific heat of water. So the value is 1. Next. That is generally you people are going to stand in water falling. You feel temperature is more, not little bit. Not 1 or 2 3 difference between the surrounding temperature, water falling. The temperature is difference because it is once I going to hit from here that the temperature rises. When I are going to fall, the temperature. That's why flowing liquid, flowing water, so what you call flowing water. If you are going to take bath, very hot. Water is hot. Am I correct or not? So now Kartik Masam, students, people are going to take water bath in rivers. That water is hot water. It should be a little bit hot. Why? Because flow water temperature is more. Flowing water or falling water temperature is more than staying water. When the water is stationary, hot. That cool only. When it's going to fall, there is a difference. Okay? Alright. Next application. The kinetic energy of a bullet, please type. Another application. The kinetic energy of a bullet fired from a gun, fired from a gun, gets converted into heat, gets converted into heat on striking the target. On striking the target, full stop. By this heat and temperature of bullet increases by delta T. Increases by delta T. So look here, when this is a bullet, what is called the kinetic energy of the bullet fired from the gun gets converted into heat on striking the target. This is the target. This is the target. It is going to be penetrate. Target. Full stop. By this, heat and the temperature of the bullet increases by delta T. Once you are going to hit it one, the temperature of the bullet increases and heat also increases. So that means work done W is equal to JQ formula. This is the work done. What type of work done? Kinetic energy. What is kinetic energy? Because I remove the velocity. Half m v square is equal to J. So what happened? The temperature and the heat also increases. That is Q is equal to ms. What is the S is what? It's generally copper into delta T. That's all. Now this m cancel. So you want to find what the rising temperature this form. You can do yourself your own way of writing the formula. These are not formula, called methods. Now then I can take 1 by 2 v square by J into specific heat of what is the specific heat of the bullet, copper. Don't. It is not formulas, sir. These are methods. This is called methods. The rising temperature is this much. How much heat is developed? MSCU into delta T. After finding this, you can find out how much heat is developed. After finding this, you can find it. So because mass cancel, J is a constant, the temperature, then you can simplify the mass with the temperature. You get how much heat is going to develop. So there, what is the unit of heat you can write? Calorie you can write, depending upon. If you are taking joule, then heat also joule. This is joule means is also joule. This is a calorie means is also calorie. Right. Now, below right. Next. If the temperature of the bullet rises up, continuation in the above this one. If the temperature of bullet rises up to the melting point of the bullet, if the temperature of the bullet rises up to the melting point of bullet, and the bullet melts then, and the bullet melts. So this bullet here is melted. Then what you got to say? Heat developed or temperature developed. So that means W is equal to work done is equal to JQT. So JQT. So that is equal to J constant. So Q is having ms delta T rising temperature, and it changes to solid to liquid. Then what are write are Q in terms of ml. Otherwise, this is equal to J into Q plus latent heater. Q, latent heater. So Q is equal to latent heater. Then we are applying this. Q is equal to. So latent heat is this much. So we call solid to liquid conversion. Now remaining everything is same. So where L is equal to latent heat. They will give the value of latent heat to the metals. Okay. What is the latent heat of fusion of ice is how much? 80 calorie per gram. Now latent heat of fusion of ice water 540 kilograms per gram. So right, this is the now m is what is this one? Because bullet is moving with the velocity 1 by 2 m v square. I am not doing anything, sir, just basic formulas. M will be cancelled. So whatever you want to find, that you can find. So m will be there. 1 by 2 v square is equal to j. This is a mass already cancelled. Specific heat of bullet. This is generally copper is bullet made into delta T plus L. So what do you want? Delta T. Simplify equal to the power. Are you understanding that?